Hey guys, part one today is we are going to use z-scores that are not whole numbers. So in order to find the percent of a shaded region that wasn't an exact standard deviation away, we're going to use z-scores and we're going to use our graphing calculator to help us out. Okay, so remember a z-score of the population, we need a value, which is our x, our population mean, and our standard deviation. This is for the population. Part two today is going to be sample z-scores, and that is something slightly different. Okay, so let's practice by just finding a z-score. So if we're looking here, if the mean is 50, okay, and standard deviation is 4, draw the standard normal curve, and we're going to find our z-scores that match. So 50 is the mean, so that means 50 goes in the middle, right? And then if our standard deviation is 4, we're going to go up by 4. 58, 62, and we're going to go down by 4. So that's going to be 46, 42, and 38. Remember, we go 3 above and 3 below. Okay? So what is a z-score for 41? Put this down. Okay? So for 41, that is not labeled on here, right? This z-score is 0. This is -1, -2, and -3. Okay, these are z-scores. 41 is not labeled. We know it's going to be in between -3 and -2, right? It's going to be in there somewhere, but we're not sure exactly where it's going to be. All right, so it's going to be here. Here's 41. That z-score is going to be in between -2 and -3. So how are we going to do it? Well, my value is 41 minus my mean, which was 50, and we're going to divide that by standard deviation, which was 4. All right, that simplifies to -9/4, which is -2.25, which I said was going to be in between -2 and -3, right? So this is -2.25 for a z-score of 41. Okay, now let's find the z-score of 55. So 55 is about right here. So again, it's not labeled. This z-score is a +1. This z-score is a +2. So we know it's going to be in between 1 and 2. So again, 55 is my new value minus my mean of 50 divided by our standard deviation of 4. Simplifies to 5/4, which gives me 1.25 for my z-score, which is in between 1 and 2, so that makes sense. Okay, so we can use z-scores or in a z-score table or a calculator to find the probabilities and percentages of the area under the curve. Okay, so this is where our calculator is going to come in. Put this back up so you can see me. Here we go. So this is where we're going to use our calculator because we can't just do the normal percentages of 68, 95, 99.7 because we're not going to be on whole numbers anymore. Okay, so graphing calculator out. There's a couple of ways to do this. All right. I have 2 instructions. It depends on what kind of calculator you have. The newer one, okay, or you might have an older one. So I have both on here. Everyone is going to put the first set of instructions is what everybody is going to do. Okay, so whether you have a new one or an old one, we're all going to do second vars. Okay, so everyone's buttons are the same. The second is the blue button in the upper corner. Vars is next to the clear button right here. So second vars, same buttons, same place. You get the same menu, whether you have a new one or an older one. Okay. Okay, from here, we also all do the next same thing. From here, we're going to go to option number 2. Okay, option number 2 is the normal CDF. Okay, not the normal PDF. We don't want that one. So option number 2, we're going to push enter. And this is where our screens are going to look a little different. Okay. Here, the newer ones, it asks you for lower, upper, your mean, and your standard deviation. This one kind of leaves it blank. You have to fill it in. Okay, so from here, we do the same order. Lower bound, upper bound, you plug in your z-scores. So if we're going to use infinity. So for lower infinity, we'll do -9 to the 99. For positive infinity, we'll do +9 to the 99. And then we'll do z-scores, and then notice my mean and my standard deviation are already 0 and 1 right here. You're going to keep it that way. Okay, remember it's z-scores. So the z-score of my mean is always 0, and then we move by 1s, right? So don't ever change those. So let's say we were going up to the 1.25, right? So I would put my from negative infinity up to negative 1.25. So the whole curve up to that point. Keep it 0, keep it 1, and push enter. It looks like this. Okay. On here, I'm going to have to actually put it in that order. So second VARS, normal CDF. Okay. So negative infinity, so negative 9 raised to the 99 is what we're going to use. There is a comma above the 7. Okay. So there's my comma. Then my z-score, we're going up to z-score of 1.25, and then you always finish it with comma 0, comma 1, and then you can close your parentheses. So now my screens look the same, okay? And then we're going to push enter, and they'll both give me the same value, 0.89, I believe, so about 89%. All right, which makes sense because up to a z-score of 0, which is my mean, is 50, right? And then I went 1 1/4 above that. So it makes sense that we're above the 50% mark, more like 89%, okay? So remember, we always plug in z-scores, so my mean and standard deviation will stay 0 and 1 every single time. After we find the z-score, that's what we plug into our calculators. All right, so let's do some examples. Let's do some examples. Here we go. So what is the probability or percentage, you can give me either one, of a z-score that is going to be greater than negative 2.91? Okay, so I have to find the z-score first. Bring this down. All right, so here's my z-score of 0, negative 1, negative 2, negative 3. So negative 2.91 is about here, right? I want to know the probability of getting a z-score bigger than that. So I can predict a very large chunk of my curve. I know that itty-bitty piece is 0.15. It's just above that. So it's probably going to be real close, okay, of everything else, right? So 100 minus that. So where am I starting? I'm starting with the z-score of negative 2.91. We're going up to the entire thing, right? So to use infinity, we're going to say 9 to the 99. All right, my mean is always 0. My standard deviation is always 1. Oh, trick. Once you start doing these, if you push second enter, what you just typed in will pop back up, and then you can change different pieces. And it works for both ones. So like even on this one, if I push second enter, what I just entered will come back up, and then I can scroll and change certain things if I want to. Okay, just a little shortcut. You don't have to use it, but it's there if you want it. All right, so here we go. So normal CDF, my lower bound is now negative 2.91. My upper bound is infinity, so I'm going to say 9 to the 99. You only change lower and upper. You never change your mean or your standard deviation. I'm going to push enter to paste it on there. If you're using an older calculator, this is what you should type into your window with your commas. So beginning z-score, end z-score, then 0, 1, push enter, and it tells me 0.998.82. So this is about 99.82%. Makes sense, right? We almost shaded the entire curve. So that makes sense. All right, let's do another one. Here we go. So now probability of getting a z-score that is less than 1.5 or negative 1.5. So here's 0, here's negative 1, here's negative 2. Okay, so here's negative 1.5, right? A z-score that's less than that. So we can go ahead and predict it's going to be less than 50%. Okay, so what is my lowest z-score? Well, that's going to be negative infinity. We're going to use negative 9 to the 99. My highest z-score is where we're stopping, which is that 1.5 of a z-score. My mean is always 0. My standard deviation is always 1. All right, so lower is -9 to the 99. That's how we type in negative infinity. Our upper boundary is a z-score of -1.5. So newer calculators, it should look like this. Once you push paste, all of our calculators should look the same, even the older ones. That's what it should look like. Then we are going to push enter. All right, and it gives us 0.0668. So it's definitely lower than 50%, right? That's only 6.68%. Again, makes sense. Think about the regions that are being covered here. So we have these bottom two, which is what? 0.15. This was 2.35. That's not a lot. This whole thing was 13 and a half, right? And we're only doing half of that. So it makes sense. Half of 13 is what? Almost 7? 7-ish, 6.5-ish? So it makes sense that our value is so small, our percentages. All right. One more together before you try one on your own. Now we're going to do an in-between. That should be a Z. Okay, so now what's the probability of getting a z-score between -2 and a positive 1.5? All right, so here's 0, -1, -2, that's nice. And then a positive 1.5, that's about right here, right? So what's the probability of getting a z-score in between those two? I like these. These are almost kind of easier. It gives you a beginning and an end. We're beginning at the z-score of -2. We're ending at a z-score of 1.5. Always use 0, 1. So my lower boundary is -2. Our upper boundary is a positive 1.5. Always keep the 0, 1. So now everyone's calculator should look the same. And then we're going to push enter. And we have 0.9104. Which is the same thing as saying 91.04%, which makes sense. We have a big chunk of our curve being covered. All right, I have one for you to try. So here I want you to try and find the probability of getting a z-score that's going to be greater than -0.91. So pause, try this one, and then come back and check your answer. All right, check your work with mine. You should have a probability of 0.8186 or an 81.86% chance. So our lower boundary was the -0.91, and then that was the lowest z-score, and then our highest z-score was infinity, which we are using as 9 to the 99 power. There is no infinity button, so we got to do something. All right. Okay. Moving on. So now we're going to add some context to our problems. So we're going to talk about how many people could do a certain thing using those z-scores. So we see there are 3. Again, there's 3 that I'm going to do with you, and then there's going to be 1 that you're going to do on your own. Here we go. All right, scores on a test are normally distributed with a mean of 160 and a standard deviation of 12. So I can go ahead and stop right there and label my curve. So my mean goes in the middle. There's 160. We're going to count by 12. Here we go. So this is going to be 172. This is going to be 184 and 196. And then we're going to subtract 12. So this is going to be 148. 136 and 124. Okay, remember the z-scores that match with these. These are all whole numbers. All right, estimate the probability that a random, I'm going to do z on the side, sorry, so you know what that is. Estimate the probability that a randomly selected student scored less than 148. All right, so first thing we have to do is find the z-score for 148. Okay, so we have 148. It's actually a nice whole number, right? So we think the z-score is -1, but let's make sure just in case. So we're going to do the value, where am I, of 148 minus the mean, which is 160, divided by my standard deviation, which is 12. This gives me -12/12, so that does prove to have a z-score of -1. Okay, so my z-score is -1. It wants to know less than that, so we're looking down here. Okay, we're looking underneath that region. So what's the percentage of that piece that's being shaded? So my lowest z-score is -infinity, so -9 to the 99. My highest z-score is -1, a mean of 0, standard deviation of 1. All right, here we go. Second vars, normal CDF. Lower was my infinity, so -9 to the 99. Highest z-score is -1. Keep my 0 and my 1 in place, push enter. Everyone's screen should look like this now. Push enter one more time, and we have 0.5186. I think I said that backwards. 1586. So about 15.86%. All right. So that was a whole number. Okay, pretty kind of what we did last time. Okay, the next one's not going to be, what is this one? Oh, the next one's an in-between. Okay, so here we go. Now we're going to go in between 154 and 184. So remember my mean was 160 in between. This was 148. This was 172. This was 184. That's all I need. So 150 is about right here, right? 154, excuse me. 154. Put that more in the middle. 154 and then 184. So the area of this piece being shaded. All right, so we know the z-score of the 184, right? We know that's going to be a 2. But I don't know the z-score of 154 because that's in between a z-score of -1 and 0. So we got to find it, okay? So the z-score of 154, we're going to take that, subtract the mean from it, and then divide by our standard deviation. 154 minus 160 is going to give me -6. And then -6 divided by 12 gives me -0.5. So we have -0.5 for my z-score, and then up to a z-score of 2. So my lowest to my highest z-score, and then always use 0, 1. All right, second vars, normal CDF. My lowest z-score is now -0.5. My highest z-score is now a 2. I do not change anything else. I push enter. Everyone's screen should now look like this. Push enter one more time, and we should get a probability. I believe it is 0.6687. Yep. So 0.6687. Okay, so about a 66% chance of getting a score between 154 and 184. All right, one more with me. Here we go. Okay, so this one, there's like a little extra question at the end. So if there are 3,700 students in the testing group, how many would earn a score of 100 or less? So we're not just doing probability. We have to find that, but then we have to apply it to how many students there were. Okay, so let's find the z-score first. Excuse me. So 160 is still in the middle. Where did it say 100? So we're going to go down. 148, 136. 36, there we go. Oh, sorry, I want to change this to 140. I apologize. All right, let's change that to 140 or less. All right, so 140 is going to be about here in the middle-ish. Okay, so the z, we have to find the z-score of that first. I take 140 minus 160, which I get negative 20, divided by a standard deviation of 12. So this z-score is negative 1.67. So remember, our lowest z-score is going to be negative infinity, and our highest z-score is going to be the negative 1.67. So negative infinity up to a z-score of negative 1.67, and we always use 0, 1. All right, so like this. Then we push enter. All of our screens should look the same. Push enter one more time, and we should have a probability of about 0.0478. So 0.0478. Okay, but that wasn't the question. The question was how many students, okay? So I know the probability of getting that score, but there were 3,700 students, right? So we're going to take my 0, take your probability. Can't write today. It's the end of the day. Okay, 0.0478, and you're going to multiply that by how many students there were. 0.0478 times 3,700. I get about 176.86. Okay, but I can't have 176.86 students, so we're always going to round up. Okay, so we're going to say about, let me type. So about 177 students would score, let's say would earn a score of 140 or less. Okay, so out of 3,700, that's not a lot, which is good. It's only what, about almost 5% of the students. Okay. All right, so we're going to pause and you're going to try one. You're going to try one like what we just did. So it has all the probability in there, and then you're going to apply it to how many of them would do something. Okay, so this one is yours. Here we go, normally distributed with a mean of 75, standard deviation of 4. So we're changing. What's the probability that a selected student scored less than a 70? So you're going to complete this entire thing, do your shades, find your z-score, do your calculator command, find your probability, and then if the question part B, if there are 700 students, how many of those scored less than 70? All right, so pause, and this one is all you. All right, ready to check your work? Let's see here. So first thing you had to do was find the z-score. So you had to take 70, subtract 75 from that, and then divide it by 4. So we have a z-score of negative 1.25. On my curve, I have marked that, and it said less than, so I shaded below. So my beginning z-score is negative infinity. My ending z-score is negative 1.25. I want all the pieces in between. So my command, so second bars, normal CDF, negative infinity is my lower, negative 1.25 is my upper, and as always, mean is 0, standard deviation is 1, because these are all z-scores, that's why we do that, have to be the same, and you get 0.1056 for your probability, so that's for part A. And then I wanted to know if there's 700 students, how many of them would score less than a 70? So you had to take your probability, multiply it by 700. You get 73.92. We always round up. So we say about 74 students scored less than 70 on the test. All right, how'd we do? Do good? So this is the end of part 1. Part 2, you're going to come back and it's all about using a sample z-score to reject a null hypothesis. So before, we looked at if things were radically different or basically the same. Now we're going to actually have values that prove if they're radically different or basically the same. So that's in video number 2. So go ahead and go to that one next. Bye.